I've been obsessing over entropy lately. It's everywhere, this idea that the universe is just winding down, everything drifting toward disorder. But I recently came across entropy, and the whole story flipped for me.
That's a wild shift, right? The core claim is that what we see as increasing entropy disorder is really just a trick of perspective. Entropy suggests that the apparent loss of order in our familiar dimensions is actually structure being redirected and conserved in higher dimensions.
Exactly. So, the messy desk in front of you? It's not just decaying into chaos. It's information moving into more complex, less visible layers of reality. That's a huge departure from the irreversible decay story we've heard since high school.
And what I love is how entropy reframes entropy as a limitation of our current measurement. We're only seeing part of the picture. There's a whole multi-dimensional conservation law in the background, keeping everything in balance.
Let's dig into the real spine of this theory. The golden ratio, phi, and its partner, psi. Entropy places them front and center not just as pretty math, but as fundamental operators of the universe.
Right? Phi, about 1.618, stands for motion and expansion, think velocity, spatial growth, that kind of thing, while psi, roughly 0.618 or sometimes negative, is its time-based, memory-compressing twin. Together, they're locked in a kind of cosmic dance.
And what's mesmerizing is their relationship. Phi multiplied by psi always comes out to -1. It's that conjugate property which anchors this whole idea that for every expansion, there's matching contraction. No energy or information is ever lost, just shuffled around.
The Fibonacci sequence gets pulled in too. Both phi and psi follow its rules at every power. So, nature's tendency to spiral, branch, or oscillate? It's encoded right into the universe's core math. It's almost poetic how math and motion are inseparable here.
That brings me to the big leap entropy makes, mapping reality onto 12 operational dimensions. Instead of limiting the universe to our traditional 3D space and time, it stretches structure across 12 domains, from basic motion to ultimate unity.
It's a pretty bold move. These aren't just spatial dimensions. Each one represents a way information or asymmetry gets stored. From phase space and field modes, all the way up to probability networks and holographic surfaces. Picture every lost bit of order just moving one layer up the ladder.
So, when we see something like heat dissipating from a cup of coffee, entropy claims that energy isn't vanishing. Instead, it's recoded in these higher dimensions, first as field vibrations, then quantum correlations, and eventually as information at the very edge of the universe.
What's mind-blowing is that the total asymmetric structure, the sum of all these dimensional contributions, is always perfectly conserved. The so-called entropy increase in our world is exactly offset by structure popping up elsewhere, in dimensions we can't directly see.
But does it hold up in the lab? I love that entropy doesn't just philosophize, it makes clear, testable predictions. For instance, it expects revival times in quantum systems like echoing coherence in a qubit array to scale by the golden ratio.
Exactly. If you time the partial recoherence events, the intervals should line up with phi, so tau2 divided by tau1, tau3 by tau2, and so on. Hone in on about 1.618. And not just in quantum experiments. Even the peaks in friction-generated spectra are predicted to show this golden ratio spacing.
It's almost as if the universe is humming in phi, whether it's energy echoing in quantum circuits or the vibration of sliding surfaces. If these phi patterns show up reliably across domains, entropy gains some real teeth.
And the best part? If experiments repeatedly fail to detect these golden ratio signatures, entropy can be straight-up falsified. It's refreshing to see a theory this ambitious that's also so willing to be put to the test.
One thing I keep coming back to is how entropy handles infinity. The 12 dimensions are just a practical slice mathematically. The framework insists the universe has infinite depth, but everything stays perfectly bounded.
And that's because of those conjugate operators, right? No matter how many layers you add, their alternating expansion and compression keep the total structure constant. It's wild there's room for infinite complexity, but never true loss or chaos.
There's also this remarkable idea that memory is never destroyed. When something's forgotten in the lower dimensions, it's actually preserved, compressed, maybe, but recoverable if you could tap into those deeper levels. In a sense, the universe is a perfect, eternal memory device.
That's huge for philosophy and even ethics. If every action, every fleeting thought is encoded somewhere in this infinite cascade, then nothing is truly erased. It makes you think twice about permanence and responsibility, knowing the universe never forgets.
Before we wrap, I have to ask, what's up with the Great Pyramid connection? Entropy claims the pyramid's proportions physically encode the same golden ratio laws at the heart of this theory.
Yeah, that's both fascinating and a bit mind-bending. The idea is that ancient builders weren't just making pretty triangles, they were expressing a universal conservation principle in stone. The pyramid becomes a kind of architectural proof that these ratios and recursions aren't just abstract, they manifest physically.
And at its outer edge, entropy gets downright metaphysical. It suggests that the mathematical structure of the universe, this intricate web of golden proportions and recursive conservation, might be the closest thing to what you'd call divine order.
So, whether you're looking at the spiral of a galaxy, the structure of DNA, or standing inside a pyramid, you're really standing inside the mathematics of the cosmos itself. Entropy doesn't just rewrite entropy, it invites us to see the universe as an endless, harmonious act of creation and memory.